Hey, what's up Node.js developers? Welcome back to a new React Native tutorial. Today we're gonna learn how to implement infinite scrollable list, and the goal for today's tutorial is going to help you master React Native FlatList. In order for you to be able to build any kind of lists such as a feed, like a Twitter feed, TikTok feed, or even multi-column Instagram feed that you can see here. So in general, I'm going to help you understand how to implement this kind of infinite scrollable list that will fetch more data from a REST API as you move and as you scroll through that list. The plan for today is the following. We're going to start by learning about the basic usage of FlatList, the API and the properties, the most important ones that we need to know about, so that if you are even a beginner, you're going to be able to follow along, but later on we're going to get into some advanced features, so make sure to stick to the end. Then we're going to learn about how to fetch data from a REST API, and specifically a paginated REST API that will provide us more pages of data. We're gonna follow that with implementing the infinite scrollable list that will load the next page as we scroll through the list and as we get closer to the end. And we're gonna implement some advanced features like pull to refresh, loading indicators, other best practices when you're working with large lists. At the end, we're gonna get into some advanced topics like performance optimization of large lists, and we're gonna implement some specific strategies on how we can improve the performance of our lists, especially if it's getting if the list is getting long. So before we get started, make sure to download the asset bundle with the starter project from assets.notjust.dev/React Native-lists, or you can find this link in the description below. So after you download that, you're gonna see the starter project and the presentation. Go ahead and open the starter project in your editor of choice. Then all we have to do is open a terminal, install the dependencies using npm install. This will download the dependencies and packages that we need in Node modules. This is a very minimal project with blank, like not a lot of packages are included. After you install them, go ahead and start the development server with npm start. This will open the Metro bundler, from where we can open either on Android, iOS, or even we can scan this QR code with our physical device using Expo Go to see the application in our on our device. I'm gonna open it up on my simulator here, and all we should see at this moment is a simple post. As you guess, today we're gonna use the Rick and Morty public API to get the data and to render our list. A quick overview of this application is everything starts in app.tsx. Here we don't need to work a lot because we are simply rendering my list. And in our source, here we keep a folder with components where we have our my list. At the moment, it's not actually a list, it's simply rendering one list item with the first item from our dummy data. In that data folder, we're gonna see some dummy data for us to get started, but in the next 5 minutes, we're going to go ahead and start fetching this data from the public API, Rick and Morty API. And the last thing that you need to see is the character list item. This is the actual component that renders one character. It simply renders the name of a character and the image. So again, in this item, we're not going to have to work a lot because we're going to focus mostly on the component called my list. After you have this application ready, we are ready to get started. And yeah, if you are also ready, let's get on this journey, shall we? Let's roll the intro. Hello everyone who is joining us live. Let me know where are you joining us from. And before we jump into the coding part, I want to say a big thank you to the sponsor of today's video, IBM StepZen. We worked a lot with IBM StepZen, and whenever we have to build GraphQL API, StepZen is our tool of choice because it's really easy to build GraphQL with a simple command line, and it scales pretty much to meet the demand of any kind of GraphQL API. What I like about StepZen is that with a simple command, we can connect our GraphQL API and get data from different sources. For example, with StepZen import curl, we can transform a REST API into GraphQL API. We can also import SQL backends like MySQL and NoSQL databases as well, similar to MongoDB. Or you can even connect it to our GraphQL backends. So the benefit is that if you're working in a big company where different teams are working at different parts of API, you can use StepZen to connect everything together into one single API that you can use on the front end. If you are interested to learn and see how you can use IBM StepZen in practice, make sure to join our stream this Friday, where we will implement a crypto price tracker. Thank you very much, StepZen, for sponsoring this video, and we are going back to the React Native lists. So let's get started by going ahead and rendering our list. First of all, I'm gonna quickly show you the data. So in this JSON file, this is an example of the response that we're gonna get from the API. This response contains two fields, the information about the response and the results. We are interested in these results because this is the array of items or array of characters from Rick and Morty. At the moment, as you can see in our my list, we are simply rendering the character at position 0 from the results. Let's go ahead and comment this out. We're gonna see a blank screen and start rendering a list. To render a list in React Native, we are going to use a FlatList component imported from React Native. FlatLists are helping us render huge lists. It helps us optimize them, implement this kind of user experiences where we have infinite lists and more. So it's very customizable, and at the same time, it's quite easy to get started. To render a flat list, let's go ahead and return here the flat list. And the flat list has two required properties. One of them is data, and the data should be an array of items, an array of data that we want to render. We're going to take it from our character.results, because this is our dummy data, and the result is the array of multiple objects. Now that we provided the array of items, we also need to tell FlatList how should it render one of these items. So this is the second required property called render item, and here we need to provide a function that will return, that will be called by the FlatList for every single item in this array, and we need to return the component that we want to render on the screen. For example, by simply returning a text hello here, and by importing this text from React Native, we're gonna see that we have a list of hello texts, and there should be probably 10 hello items, because that's how many characters we have in the result array, from 1 to 20, actually, yeah, 20. A good thing to know is that this render item function, the FlatList, when calling the function that we provide, will give us some data, will give us some information about which item it is currently rendering. This data is going to be inside an object, so let's say data here, and we can access it by calling data.item, or let's start with data.index. There will be the index, which will specify the index of item currently rendering, font size 30, and we can see 0, 1, 2, all the way till 19. So one of them, of the data points inside this parameter is going to be the index. Usually what we do is we go ahead and right away destructure this information. So I'm going to destructure index here. I didn't want to do it right away because sometimes this syntax is confusing, like why do we have so many parentheses? But if you understand, like, yeah, one of them is the portal, one of them is the function parameters, and one of them is destructuring the index from the data, now probably it makes a bit more sense. But usually we don't need only the index. Usually what we need is actually the item that is being rendered. So if instead of rendering the index, we're gonna render item.name, we're gonna see that now all of these components are rendering the actual name that is coming from our data here. So at the end, FlatList will call our function for every single item in the array of data, and then will send us the actual object or the item itself that is being rendered, so we know like what to render on the screen. With this information, instead of rendering the text, what we can do is we can render a predefined component like a character list item, and we're gonna send here the character, which is our item. So just like that, we have a scrollable list with images and all the items here. I don't think we need the index at the moment, so let's keep it like this. And yeah, that's the minimal things that you need to do in order to render a list of items. You need an array, and you need to tell FlatList how should it render every single item in that array. That's the basic. And also I'm gonna show you how you can style a bit this, the whole FlatList. To style it, we can give here a container style, and these styles will be applied to the container that wraps around all our content. So by giving here a property gap, for example gap 50, that's how we specify like the space between the items in the array. So now we see that there is 50 pixels between the two items. If I'm gonna increase it, it increases. So that's usually how I add spacing, and a gap of 10 probably is going to be enough between the items. Okay, so yeah, that's going to be our first basic usage of FlatList. Let me go ahead and do git add, git commit, -m, basic FlatList. Let me check the live chat. Haven't checked it. Hello, Julio. Hello, Ouseni Parsido from Namibia. Waiting for the food application with Supabase. Yes, we have a very huge full stack and full tutorial about React Native and Supabase, which is releasing on 6th, right? 6th of February. So it's going to be probably next Tuesday. Yes, exactly. Julio, yes, check out, follow this tutorial till the end, and it will help you on build like the menu and nest it with FlatList. If you all have any questions, guys, make sure to write them in the chat, and I'm gonna try to stop from time to time and help you. Let me start a quick poll. Let's see how many people are a fan of Rick and Morty. Have you watched it? Did you enjoy it? Anyway, the next step. Our next step is going to be to switch from using dummy data to actually querying the data from an API. For that, usually what happens is instead of using this, we keep the items or the data that we need to render in an array, in a state variable. Why do we need a state variable? Well, because usually the items that we render on the screen is something that will change as we scroll. As we load more items, we will add into the same array. So in order for this to automatically update on the screen, on the user interface, we need that in a state variable. So let's import the hook use state from React and start. I'm actually going to remove this return statement to keep it simple. Let's define the items and set items using use state, and here is going to be an empty array. Now here is where we put the default array. If I'm gonna go ahead and put here the character dot results And if these items we're gonna send to the data array in the FlatList, what we should see is we should see the same response, the same output. But usually our state is going to start with an empty array. So if I'm gonna switch to empty array, that's what we're gonna see. Now we need to load the first batch of items. We need to send the first request to the API and load the first batch of items for our list to render here. What we are gonna do is we are going to open the Rick and Morty API. So let me open this Rick and Morty API.com. Here it should be. And let's go to the documentation. I was looking for a very easy way to integrate for a very easy REST API, and I think Rick and Morty is one of the best ones. So let's go ahead under the basically what we have to do is we have to send if we go to the character, get all characters. This is information of how we can get all the characters. All we have to do is send a request, a GET request to the rickandmortyapi.com/API/character. If I'm gonna copy this URL and simply put it in my browser, I'm gonna see the results. I'm gonna see 20 items here. For me, I have a plugin, so in your case, it might look something like this, but in my case, it parses it. So here we see a lot of information about these characters, like the name, status, the episodes it appears in, the URL, and so on. So let's go ahead and from our React Native application, send a GET request to this URL. To do that, let's go ahead here in the My List. And first of all, where should we send this request? We should send this request as soon as the My List is being rendered. To do that, we are going to use a use effect. So let's define the use effect that will have the dependency array, which is the second parameter here, an empty dependency list. So if there is no dependencies here, the use effect will be executed only once when the component mounts. Here, let's go ahead and define a function fetch items, which is going to be an asynchronous function. All we have to do after we define the function is simply call this function. This is a usual weird API of a use effect because we cannot have async functionalities here, so that's why we need to define a function and then simply call it. But now inside this fetch items function, what we can do is we can send a fetch request to get these items. So response equal to await. Using the fetch API, which is built in React Native, we can pass here the URL that we copied, rickandmorty.com API character, and let's go ahead and do a console.log response. I think we have to parse the response as JSON. So if I'm gonna go into the Node.js here, yes, we see that the response is still as a blob. So all we have to do is const response JSON equal await response.json. This will transform the response to JSON. So now we can console log the response JSON. Now if we're gonna look, we see the information, we see the object with information and the results, which is the array that we need. If you want to have a better view of the JSON that was returned here, instead of simply console logging the response, we can do a JSON.stringify, and this will stringify the JSON. And if we send as the third parameter the value 2, that will indent the different levels with 2 spaces. So this will be a more user-friendly way to view a JSON object in our console. So now we see that the response has 2 fields, the information, which has some information about the request, and the results, which is an array of characters. So that means that if I'm going to take the results from response.json and put them in the items, I expect to see them here on the screen. So let's do just that. Set items is going to be response.json dot results. If I do that, here we have it. Here we see the array of the first 20 characters from Rick and Morty. I'm gonna go ahead and delete the console log from here and only leave the 3 lines. Fetching, transforming to JSON, and setting it in state, and later this state is being used to render the list. So this is the first step. This is the initial fetch. What usually we can also do here is we can manage the state that will represent whether we have finished the initial fetch or the initial loading of data, because with that we will be able to render a loading indicator. So by having here maybe loading and is loading, let's say that initially the loading is going to be false. When we start fetching, let's set the loading with true, because we are starting to load info items. Loading and set loading. And when we finish this at the end, we're gonna set it back to false. So as long as we are waiting for data here, our loading is going to be true. And if is going to be true, instead of rendering the flat list, we can do here if loading. We can render, let's say, an activity indicator. An activity indicator from React Native is a simple spinner. So right now, it will be very fast. I am able to see it, but yeah, basically, the more we're gonna wait here, the more, or the slower the internet, the more we're gonna see that. And one way to test that would be to open the terminal, press C to get the menu, and then press J to open the debugger in Expo. And here under the network tab, let's try to, why cannot zoom in? Let's try to, under throttling, let's do a slow 3G. And after that, if I'm gonna reload, it's still very fast. Even offline, doesn't look to work here. The throttling. Yeah, so maybe later we'll simulate like a longer wait time here. Like if I'm gonna comment everything out, we see that it initially sets to loading true, and we see the loading indicator at the top. Now that will give some feedback to the user of what's happening behind the scenes. Like, hey, wait a bit, we are loading the data. Okay. With that being said, let's go ahead and commit. Git commit. We're going to say that, yeah, fetch data from REST API. Perfect. Oh, I see that a lot of people haven't watched Rick and Morty. I recommend you to do that. Pretty cool. Hey, first time from Germany. Hello, Mino Terry. How are you doing? You're welcome here. And if you're the first time here, guys, and if you want to become a React Native developer, if you want to improve your React Native Expo development skills, make sure to subscribe to the channel. We're very close to hitting 100,000 subscribers. And on this channel, we do a lot of React Native tutorials. And we do them very like hands-on and project-based. You're gonna love them. Can you explain the usage and the purpose of the on and reach threshold? Yes, we're gonna do that. We're gonna do that in the next steps. Hope you're gonna start explain how to start loading new items before reaching end of a list, as it makes slicker user experience. Exactly, that's what we're gonna do. That's the whole point of the infinite loading lists. And as you scroll the list, you don't have to reach the bottom of the list in order to start loading the next data. We can add like a threshold where we start loading the list as we scroll down. So this way the user that scrolls doesn't feel that, hey, there is some loading happening behind the scenes. It's very sleek, like it feels that there is always the data that you need to have there. So that's exactly the purpose of the tutorial. So we're gonna get into that very, very shortly. Okay. So let's continue with the tutorial. Watching from Indonesia, hello. Philippines, hello Aman. Okay, so what do we have here? I'm gonna get back to the questions after finishing the next feature, so stay here, stay tuned. But now the next step is going to be to actually start working and learning about the pagination. Pagination. Well, first of all, the pagination starts on the backend. It starts on your API because it's the API who is sending you paginated data. The next step is going to be to manage this pagination response and to merge them together on our front end to render like a full list of items. But let's start with the backend and let's see how the Rick and Morty API is implementing pagination. If we look at this get all characters API request, here it's not gonna say, but if we go to the REST page, here we will see the information. Oh yeah, there is a dedicated page for info and pagination. So the API will automatically paginate the response. Basically, without us having to do anything, we're gonna receive only 20 documents per page. Even though there are more than 500 characters in Rick and Morty, we only see the first 20 because it automatically paginates. And that's usually how APIs do, because even if you don't specify like how many items you want, like it will make sure to give you a reasonable amount. Some cases that's 100, 50, 10, 5, 1, and so on. But make sure you know like how many items you get initially. The information, we saw the results, which is the array of characters, and we also receive the information. This info object of the response provides information about the request itself and about the pagination. It specifies us how many items there are in this list with a count object. So we see that there are 826 characters. It also specifies how many pages in total there are, and it specifies us the URL to the next page and the previous page. The URL to the next page, as we can see, is the same URL that we sent initially, but it has a URL parameter called page2, for example. And if we're gonna go to the first one, we see that the next is page 2. If I'm gonna click it to open it again, we see that the next here is page 3 and the previous one is page 1. So the pagination on the API works by sending a URL parameter to our API with the page number. This is one type of paginations on the backend where we specify which page we are on. This kind of pagination is inspired, or not inspired, but it's coming from the, let's say, where is it? Let me find an example. Yeah, it's coming from like this kind of old school pagination where we have a list of pages and we can click around like from page 1 to page 2, page 3, page 4, and so on. And because, yeah, we are only specifying like what is the page number that we want to retrieve information with. That doesn't mean that we cannot use this with infinite lists. We definitely can, but in a lot of cases when working with other types of paginations, you might see paginations that have two parameters, that are working based on two parameters. They're working on the limit and offset. The limit is how many items do we want to get, and the offset is how many items do we want to skip. If you think about it, it's kind of the same as here page, because if we know the page size, which in this case is 20, the page 30 would be limit 20 because we want to get 20 items, offset 40 because the first two pages, the first 40 items we want to skip. But let's not get into those technicalities, and let's simply go back to our application and think about how to manage pagination here. So as we saw, like if I'm gonna do a console log here of the response.json.info, we're gonna see that after the response, we receive an object that contains the next page. This is the URL that we need to query to get the data about the next page. So let's go ahead and save it into a state variable. Next page, set next page equal use state, and initially it's going to be probably empty. Now, after we set the items, let's also set the next page in our state. And the next page is going to come from response.json.info.next page, because we saw that's the URL with that we need to query to get information for the next page. So with this next page, what I'm gonna do, I'm gonna start by rendering it as simple as possible in the list footer component. List footer component is a property of FlatList that helps us render items below our, components below our items. So if I'm gonna simply render here a text with next page, and if I'm gonna scroll down, nothing happens. Let's do here a console log, next page. Next page is undefined. Why? Because maybe, yeah, it's not next page. It's simply next. So my bad. Info.next. Now if I'm gonna scroll down, at the end, we should see the URL to fetch the next page. So, how do we fetch the next page? Knowing the URL, basically we need to do something similar to here. We need to send a request, we need to parse it, and we need to add it to our array. What I'm gonna do here is, let's start by moving the fetch items out of this use effect in order for us to be able to call the fetch items in multiple places. Yes, we need to fetch the initial items when the application loads, but we will also want to fetch the items when we want to load more. I will start by, instead of rendering here the next page, I will render here load more, and maybe I will add a style like align self, center, font size. I will start by having like a button load more and having to press it, and then we're gonna improve it by automatically sending this request. So font size, load more, and font or color, and no, blue. So if I'm gonna go to the end, we see the load more here. If I press, what I want to do is on the text on press, I want to call the fetch items. The fetch items or the fetch next page. Or let's call here load more. Let's call load more. Yeah, let's call load more, and let's go ahead and define, besides fetch items, let's define below it a function called load more, which is going to be an async function. And we will start by doing console warn loading more. So if I go to the end and press load more, we see this warning loading more, which means that we are calling this function correctly. So what should happen in load more? Well, we should basically do something like this. So I'm gonna copy everything here from fetch items to load more. But the only thing is that we're not gonna fetch the initial URL, but we're gonna fetch the next page. Then we're gonna get the response. I'll start like this, but we will have to update this. And also we're gonna update the next page. So now if I'm going to refresh, we see that the first item is Rick and the second one is Morty. If I scroll to the end and press load more, we're gonna see that the first item now is Aqua Morty and then and so on. So we see that these are data about the next page. So if I do again, we see the third page. If I do again, we see the fourth page. This looks like a usual traditional or like, let's say, old school pagination type where we move from one page to another, but this is not how usually paginations work in mobile applications. Usually by loading a new page, we simply want to append the result to the end so that we can scroll back and forth, starting from the first item all the way to the end. So that means that when we call the set items, I don't want to replace the array of items with the result. I want to append the result into the existing items from our state. This way, we still have the previous page and the new page, not only the new page. To do that, the setter in React Native or in React can receive two types of parameters. One of them is the value. If you send a value, it will simply replace the state value with your value that you are sending. But if you're sending here a function, what it will do is it will give you the existing items and you can update the existing state. You can provide an update function. For example, what I want to do here in the update function is, knowing the existing items, I will create a new array where the first items are the existing items, and at the end I will destructure the response.json.results. This way, we are creating a new array where first items are taken from existing items that we have, and then at the end we append the new results, the new items that we receive. So now, if I'm gonna go to the end of a page and press load more, we see that we still have a Rick Sanchez, and if I will scroll after this ends in my eyes Johnson, we see the next page as the next page. And if I do load more again, we see that again here. So now what we managed to do is we managed to merge together the data of different pages that we receive from the backend into the same items array. And as we scroll, this array will simply grow in size so that we can scroll back and forth from different items. The problem is that now, because we have the same set loading here, you saw that we are being redirected to the top. So if I press load more, we are being redirected to the top. Why? Because whenever we are doing this load more, we are actually getting into this if statement because we are loading and we are rendering an activity indicator and not the flat list. And the next time it renders the flat list, everything starts from the beginning, like it starts to render from the beginning. So we want this activity indicator only for the initial load. So there will be, we can have another state variable, or is going to be loading and set loading, and another one for loading next page, set loading next page. Initially, that's going to be false as well. So the first one is going to only be responsible for the initial fetch, for the initial loading of items, because that's what I think I can do that with one state variable, you know? I think I can do that by taking a different approach to it. By instead of, so yeah, switch back. Let's try to use one state variable instead of two of them. So instead of doing if loading return activity indicator that will prevent the rendering of the flat list itself, I'm going to comment this out. So I'm going to do this if loading inside the list footer component. So inside this list footer component, let's do here a view that will have the text load more, but it will also have, let's import the view from React Native, a view. So in this view, besides the text of load more, we are going to have a conditional rendering of the activity indicator if we are in loading state. So this way, the activity indicator will always be below the existing items, and at the same time, the flat list is always going to be rendered. So I can remove this one, and I can restart here. We see the loading at the top, but as we press load more here, we see the loading indicator there, and we are not redirected to the top. We stay at the same scroll position and we can go to the next items. So this is the loading indicator using the footer, list footer component. Load more, it shows the loading indicator, and it loads the next set of items. Okay, now what I'm thinking is that we have a lot of similar code here in the initial fetch items and in the load more. The only difference that I see is the URL that we are sending. Can we think of a solution of how we can merge them together? Well, if we look at the load more, it works with the next page. The initial request works with the initial page. What if we take this initial page and set as the default next page here? Then what if we, instead of call I'm going to call this load items at the initial load. So now it works. I'm gonna scroll. If I press load more, it loads the next page. So now we have only one function that does the fetching. So let me think of a better name. Not load more, but fetch next page. So we fetch next page when we mount the component, and because the next page initially has the initial URL, that's what is going to be fetched. Later on, the next page URL is going to change based on the response. And here in the text, we're going to call the fetch next page. Yeah, let's see. Yes, now everything works. So this is the basic pagination with a simple button load more. In the next step, we're gonna do this automatically. But before that, let me go ahead and do a git add, git commit, basic pagination. And yeah, I can even do git push origin. And the URL to this repository you're also going to find in the description below. And I'm also going to try to add the end result as a source code in the asset bundle. So if you're watching this later, you should see both the starter and the finished product. How are you doing, guys? I see that a lot of people are interested in this topic. And if you are just joining and you're wondering what we are doing today, what we are doing is we are implementing an infinite scroll list, and the whole goal is to help you master React Native FlatList. That's why we started slow. We started with learning about the basic FlatList usage. We already learned how to fetch data from our REST API, and specifically paginated data. And now we are at the step where we will implement this infinite scrollable list. What we want to accomplish is, as we scroll through the list and as we get closer to the end, we want to send this request automatically so that the user doesn't have to press any buttons for pagination. This gives the user the impression that the list is infinite and he can scroll through it and there is always data there for him to look and consume. What we will also implement today is loading indicators, which we already saw how to do, and things like pull to refresh. And at the end, the most important is the performance optimization of large lists. We're going to talk about that, we're going to learn, and we're going to try to improve the performance of our list by implementing these tips and best practices around this. And if you are interested, if you're a React Native developer, if you want to get better at it, make sure to subscribe to the channel for more tutorials like this in your feed. That will help us a lot and will mean a lot to me. Anyway, let me check the live chat with questions. Are you going to use React Query? No, I'm specifically trying to do everything with simple state variables, even though using a library that is dedicated to manage like this request, like React Query or other libraries similar to that will simplify a lot of things. I really want to show you the basics, the fundamentals, so that you understand what's going behind the scenes, what's happening. And after you understand these basics, it's going to be much easier for you to integrate with React Query and so on. So it's going to be pure use state in FlatList. Fulbright, hello from New York. Hello. Will the FlatList be able to render up to 5,000 characters if we keep appending the fetch data? Yes, it will, and we're going to learn that by the end of today's video when we will talk about the performance optimization. Just a quick snippet of like why it manages to do that is that, in fact, the FlatList is smart enough to optimize the amount of items it renders, or the amount of items the amount of items it renders. Because if you have 5,000 items and you are currently looking at the item number 1,000, most probably you're not gonna get to the item number 1 or the item number 5,000 instantly. So FlatList is smart enough to ignore and not render it at all. It will render only a couple of items, like let's say 10 items before and 10 items after. And as you scroll, it will check your scroll position and will switch this window of what items it should render. So this way, it's going to support any amount of sizes if you implement it correctly. And a lot of things are actually by default in the FlatList. There are some things that we can tweak to make it even more performant. Stay hydrated. Yes, let's stay hydrated. Hello from Vietnam. Hello from Kenya. Hello, guys. Welcome here. I may have missed it. Are you using TypeScript? Yes, I'm using TypeScript, but I'm not focused on that. This will work in any situation. Which plugin to use to show data clean in the browser? JSON formatter or something like that. It was a Google Chrome plugin. Watching from Israel. Hello. From Puerto Rico. Hello. Vladimir is saying, in one of my real applications with 50 pages, the FlatList became problem, so I switched to the FlatList. So yeah, stay here till the end, and we're going to talk about that, about performance and how we can improve it. But yeah, FlatList is a great alternative and a great, like a drop-in replacement for FlatList that promises us better performance. But we can achieve great performance with FlatList as well. Anyway, let's continue because we still have a lot of things to do and to cover in today's video. So next step. Yeah, the next step is going to be infinite scroll and infinite pagination, because at the moment what we have is we have this pagination that works in the list, but we have to manually press this button to trigger the function fetch next page. What we want to do is we want to automatically trigger this function when we get close to the end. There is a callback function that we can send to the FlatList, and the FlatList will call that function when the scroll reaches the end of a list. The property is called onEndReached, very easy to memorize, and here we need to specify what function do we want to call. We want to call fetch next page. Just like that, if I'm going to refresh, check the, let's call here fetch next page, console log fetching, and here let's specify the next page that we are actually fetching. Now, if we look here, we're going to see the next thing. We are fetching the character. We're fetching it 2 times. That's the first problem. Fetching 2 times. Well, this problem this leads to actually showing us that we have 2 problems, or let's say a problem and 1 performance improvement that we can do. So why do we fetch initially 2 pages? Well, because once we are calling the fetch next page in the use effect when the component mounts, and the second time, because the FlatList mounts with an empty list, the onEndReached is called, and we call again the fetch next page. So that means that this use effect shouldn't be here, but it also means that the fetch next page function should be smart enough to stop the execution if it's currently loading, in order for us not to send multiple requests at the same time. So a simple if loading then return will stop the execution and will not go further if we are currently loading. So now if I'm gonna open this up, we're gonna see that only one request is being sent. So that's good because we are not sending multiple requests, but at the same time, I think we can safely remove this use effect because the flat list will start and being rendered with an empty list and will automatically send this on and reach fetch next page. I think it should be fine like this. So if I will refresh, we see that it's fetching the first page because it reaches the end. And here, whenever we have arrow function that calls a function, I like to simplify it by simply sending here the reference to the function. So when you reach the end, call this function. Now let's open the terminal again and see the fetching, like how many times we are fetching. I'll start scrolling and I'm not gonna press on anything. I'm just gonna scroll, and as we get close to the end of a list, we should see a new request being sent. And here I'm very, very close to the end. Boom, the next page is automatically being fetched because we reached the end. Now we're gonna scroll, and when we reach the end, the next page is being called. When does this happen? Well, first of all, congratulations, we already have infinite scrollable lists. I don't have to press on anything, it automatically fetches. That means that I can safely go ahead and remove this load more text because we don't need it anymore. And the list footer component can also be simplified. I can remove a view and I can only leave here this. If it's loading, a return activity indicator. So now, it's not sending the first request anymore because it doesn't understand that we reached the end if it doesn't have any footer. That's interesting. If I do back and have a view, will it send this request? No, it doesn't. Why it was doing it before? Text footer is just the presence of some text there, the reason that the initial one is rendering. Yes, because if it doesn't have anything there, you see it doesn't trigger the fetch next page. That's tricky, and I would expect, like, I understand why it might happen, but that's a bit tricky. So it calls the on and reached when we don't have any items, only when there is something in the footer. If there is nothing in the footer, it will not call the initial fetch next page. So in that case, I think it's a better solution if we send manually the fetch next page for the initial load. The initial load happens in a use effect with empty dependency array. So let's simply call fetch next page here. So this way, no matter if there is a footer or not, it will still fetch the initial page. And because we are preventing this function to be executed multiple times, we are not afraid to call it multiple times. It will stop and will actually send only one request. So now, yes, it works. If I go to the end, it loads more. So yeah, now I can remove this view and I can only leave the simply list footer component. If it's loading, return the activity indicator. So as I said, congratulations, you now have an infinite loading list that when reaching the end will load the next page and we can scroll through it. But that's not it. On and reached, it has another property that it works great together, and that property has a default value. And here I'm talking about when should a flat list consider that it reached the end. Currently, let me comment it out for a second just to see, to show you which is the, which is the last item. The last item is this ant in my eyes Johnson and the antenna rig. Let's see when fetch next page is being called. So as I scroll, and as I reach probably the last one here, you see I'm reaching the ant in my eye Johnson, which is not yet visible, but as it's visible and as I reach the actually when I reach the end, then it calls the onEnd reached. This is okay, but this means that the user, if he will scroll fast, he will be able to reach this end and will see a loading indicator, and you'll make the user wait for a bit. A better approach is going to be to be proactive and say that if we are close to the end but didn't yet reach it, then call the onEnd reached. This can be adjusted using the onEnd reached threshold. And here if I will provide a value of 3, that means that if there are 3 screen sizes of the list below, if there are less than 3, then call the onEnd reached. So now, if I will reload, we're gonna see that we call this page we call this page a little bit earlier. As we get here, we already see the next page, but there is still 1, 2, and 3 in the first page. Remember the ants in my eye Johnson. So the property onEnd reached threshold allows us to adjust when should the FlatList call the onEnd reached, and the value, it represents how many available screens there are below when to do this. So for example, 3 can be a good value. You can even do 5 if you want to load like really early, so that the user here we see the next ones. As we scroll, we should see the next ones. Come on. Yeah. And this way, we are really preloading a lot of them. So even if I scroll really, really fast, I never seem to reach the end, you see? And I already have like 9 pages or around 200 items. And I can scroll back through 200 items with images. All right, so this is the power of the onEnd reached to automatically fetch the next page and the onEnd reached threshold. Do you have any questions so far? Let me go ahead and commit this one. onEnd reached and onEnd reached threshold. If you look into the documentation of FlatList React Native, you're gonna be surprised that there is no information about the onEnd reached. Well, there is no information about this property because this is a property specific to virtualized list, and because FlatList is a component that implements virtualized list, we are able to send this to the FlatList, and then the FlatList will give it to the virtualized list. So what you can do is simply in the search onEnd reached. It will open the documentation of virtualized list, which is the base component that stays behind the FlatList, and here we can search for the onEnd reached. So the documentation says onEnd reached is called when the scroll position gets within the onEnd reached threshold from the logical end of a list. So the next point is the on and reach threshold. And this information is quite interesting to understand, like how far from the end in units of visible length of the list the trailing edge of a list must be from the end for the content to reach. So yeah, I understand like the documentation is a bit weird, but basically like one way to think about it is how many screens the content that is below, that is loaded below, how many of them can fit on the screen. But in fact, it's not actually the screen, but it's actually the viewport where the list is rendered. Yes, in our situation, we are rendering it full screen, but in some situation, we might render it like a smaller, like height 200. So in a height 200, style, maybe I can do it like on the parent component. Like if the list is really small, that means that how many of them are below. Fulbright, I like saying I like your VS Code and Git setup. Just check on our channel, search the VS Code setup, or go to YouTube, search notjust.dev VS Code setup. Add debug true to the flat list. Debug equal true. Set. Oh boy. You live, you learn. Thank you very much. I didn't know about that. What happened here? Is it from the debug? I saw what's the potential of this debug, but for some reason it's giving me an error. Weird, for me it's not working. It's only working like after initial load. So if I just add it now, yes, we can see like what is currently rendering, and as we scroll down we see the amount of lists of items. Cool. And we also see like that as we scroll, the items here are not being rendered, even though the ones at the top are rendered, because we can at any point press on this one and go to the top. So it's smart enough to keep the items on the top rendered. The ones that are very far from our position, which is indicated with this red dot, it's not rendering. That's really powerful tool to debug the performance and the rendering of your flat list. And thank you very much for sharing that with me. So as you scroll, you see that only the items that are close to your current scroll position are being rendered. But we're going to talk about more when we will do the performance. And for some reason, just having this debug here is not working for me. It only works after adding it like this. But yeah, we will know to use it when necessary. Okay, so git status. Perfect. So that means that we are done with the infinite scrollable list. We saw the loading indicators. Another step to cover is going to be our pull to refresh. This is a very common functionality when it comes to building and rendering list. And it happens when we get on the top of the screen and we want to update the screen, usually the experience is to pull down, and then this will refresh and will resend the request. To do that, what we can do is we can use a couple of properties on the FlatList. One of them is refreshing, and refreshing should be a value true or false, whether it's refreshing or not. So I think we can use the loading here to do it. And the next one is the method on refresh. On refresh, I can do console.warn refresh. So now when I'm going to pull down, we see the refresh. And it only happens when you actually release it, when you get to the end of it. So as I will pull down and drop it, we only then see the onRefresh method being rendered, being called. And the refreshing here, I'm not sure if it will not mess with the loading state, because when I will scroll and as it will load, no, I think it doesn't mess with that. Everything is working perfectly. And I can go here, can do that, and it will call the refresh. Let's actually refresh. So let's, instead of doing that, let's do on refresh. Let's call a function on refresh that we will implement here. Console, well, not console, but const on refresh equal a function. Oh, come on. A function here that should do what? Well, initially it should reset a lot of these things. For example, it should reset the items to set items to empty array. Next, it should reset the next page to the initial page. For that reason, let me move this one to the const initial page equal to this one, because we need it both here, but we also need to reset which is the next page to be fetched when we pull down to refresh. So here initial page, and let's reset the set next page when we refresh. Set next page to initial page. We want to start from the beginning to send the request, to send the initial request. And now if I'm gonna do refresh, it's basically going to remove everything and start from scratch and only update the next page. The last step here is to go ahead and call the fetch next page like this. So if I will do refresh, oh, I know why. I know why this is happening. This is happening because we are resetting the next page to the initial page, but the setter or setting and updating a state is asynchronous in React and React Native. That means that after calling set next page, we cannot expect here the next page to be updated, because it's going to be updated in the next re-render. It's a very small console.log next page. It's a very small detail, but very important in this situation where, for example, I'm going to do refresh. We see that the next page is this one, but it's fetched. Next page here, what? Oh, because I'm rendering the initial page, I wanted to do the next page. So after calling a setter to update the state variable, we cannot expect it to be automatically or right away updated here. It will be updated during the next re-render, and here we can see that by refreshing, and we see that the next page is the existing page and not the initial one that we expect. What we can do here is to the fetch next page. Let's leave that one. Let me think how to better approach it. Fetch next page. Initial page. One way would be to, instead of using a state variable in the fetch next page, which is actually going to be a better approach, instead of using the next page here, is to receive here what is the URL, or fetch, and call it not fetch next page, but fetch page, and send here a URL. This way, let's see in other places where we call it. In the use effect, we're gonna fetch the initial page, right? And now we don't even need to initialize it with initial page, because next page, there is no next page. And in the onEnd reached, here I'm going to go back to a Lambda function and call fetch page, and here we're gonna fetch the next page. Now everything should be working as it was working before, hopefully. Actually no, because in the fetch page we need to use this URL of type string, and this URL we're going to pass here, fetching URL here, and that's it, because next page, we don't use it anymore here. Perfect. This way, it's more flexible of what URL we're fetching when calling this function. And on refresh, we can go ahead and do fetch next page, also initial page. Let's do it like this. And there is no fetch next page, it's the fetch page, we renamed it. So now let's see if the loading of the next pages is working as it was working before. Yes, it is. We load more items. If we go to the top and scroll down, it will reset the items. It will set the next page to the initial page, and it will fetch the initial page. And in this case, I don't even think that we need to reset the next page, because we are simply using it here, and it will automatically reset when we get the response, but let it be there. So just like that, pull to refresh will update our, will send a new request with the data. So we can see this by looking at what requests are being sent. So as we scroll, we see that we load page 2. Here we see page 3, page 4. I'm also going to add the debug here so that you can see the sizes of that list. Yeah, now we have a lot of items here in this list as we scroll. And if I'm gonna go to the top and do a pull to refresh, this debugger is messing with me. I just wanted to say that, yeah, basically we are resetting to the initial page. Page 2, if I go to the top and pull to refresh, we are sending the initial page request, and we basically start from scratch. So this is our pull to refresh, and it actually needs both of these: on refresh, which is the function to be called when we pull down, and the refreshing, which is a boolean that specify if it's currently refreshing or not. Because without that, we should get an error saying that the refreshing prop must be set as a boolean for the on refresh to work. So make sure to add the loading, add the boolean loading for the refreshing here. Perfect, perfect. Let's go ahead and commit everything. Git commit, pull to refresh. All right. So this is another goal accomplished for today. It's the pull to refresh functionality. And the last thing that I want to go into today when we talk about working with large lists, especially paginated lists, is about performance. How to improve the performance of large lists, how FlatList is improving the performance of your list and how it works. So that's going to be the next step. Before that, let me check some comments. Vlad Shushpanov is saying, is there on start reached with dynamically added items? On start reached. I'm not sure if there is such a thing. And I'm thinking where you would need it. But there is a use case for that, definitely. For example, on Twitter, when you go on the Twitter, it puts you it shows you a list with your last tweet that you saw in the middle, so that you can scroll down to load more items, like older items, and you can also scroll up to load more recent items. I think you can accomplish that by hooking into the scroll. Let me see. Give me just 1 second. Let's see here. Oh, there is on start reached. Good question. And the answer is yes, there is. Called once when the scroll position gets within the on start reached from the logical start of a list. It works similar to on end reached, but only for the top. Perfect. Ivan, здорово. Привет. Всем привет, Dmitry. Hello. Yes. Come on, why it doesn't scroll? Okay, guys, so let's talk a little bit about the performance of our list. I want to show you a great blog post from React Native that is specifically talking about optimizing FlatList configuration. So if you go to the React Native docs, to the performance, you're going to see here optimizing FlatList configuration. So let's go through this blog and understand the best practices and the recommendation that we get for optimizing our flat list and to understand better how it works. So first of all, as I was saying, behind the flat list, React Native is using a component called virtualized list. And React Native, the flat list is the implementation of a virtualized list concept. Here we're going through some terms to understand what we're talking about. Memory consumption, how much information about your list is being stored in memory, which could lead to an app crash. So the long story short is the more items you keep loaded in the memory of a phone, the faster or the more performant your FlatList will feel when scrolling through it. But that means that if you on low-end devices, you're not going to be able to load a lot of those data. So you have to be smart about which items you load in memory and which one you basically free out from the memory as you scroll through the list. A lot of these things are happening, are implemented by the FlatList behind the scenes, but it's important for us to understand because a list of 5,000 items, we're not going to be able to load everything in memory. There is not enough memory on devices for that amount of data. The responsiveness is is the application ability to respond to interactions. So low responsiveness is when you touch a button and it doesn't respond to your events. Blank areas. This is a very common issue of a FlatList, and this happens when the virtualized list cannot render our items fast enough when we scroll very fast through the list. So if you have a lot of items and you scroll like really fast, on some devices you might start seeing blank or white parts of a FlatList. This is because when we scroll, and as you saw, like if I will do here debug through, you're gonna see that the FlatList only loads in memory the items. What's going on here with the fetch next page? Did I break something? I think I broke something. Give me just 1 second. Okay, doesn't seem to be broken. But anyway, I'm gonna load a couple of pages just for me to explain like what do I mean. And probably I'm also going to, let me make this one bigger. And maybe let's switch a little bit the positions so that you can see better what I'm talking about. Okay. So if I put debug through, yeah, there is this window of items, and the red dot is what we currently see on the screen. Everything from top to bottom, that's the whole list. So as we scroll, the items from before are stopped being rendered, and items on the bottom start being rendering. This way, the FlatList keeps the memory optimized and doesn't have everything in memory at the same time. And in fact, what it does, it will render 10 screens or units of length before and 10 units of length below. So let's say 10 screens above, 10 screens below, and the screen that we currently see here. So the problem with blank areas that is described here happens when we scroll so fast that the FlatList doesn't manage to start rendering the items here, and the red dot will go into this blank area. At the moment, that blank area is actually not being rendered. It's completely white. It only keeps track of like the sizes, and that's it. So yeah, I'm not going to be able to do it here because this iOS is quite powerful. Maybe it would be smart to maybe use an Android device for that. Anyway, going back, so the viewport. The viewport is the visible area that is being rendered to the pixels. So at the moment, the viewport is our screen here, and this is the area that is being rendered to pixels. In the debug view here, this is the red area. So I'm gonna refresh, add the debug. So the red area is our viewport, what the user currently sees. Having the debug leads to different requests. Maybe for the on refresh. Let's do here if loading. Let's do return as well. So the viewport is the red area here, the things that the user actually sees on the screen. Now the window is the area which items should be mounted, which items should be, let's say, rendered. This is generally much larger than the viewport. The window in this case is the amount of items, the orange items here, that I think are not correct. So yeah, the window is all the orange items that are being rendered. So it contains more items on the top and more items on the bottom. Okay, let's go ahead for a list of props that can help us improve the performance of the FlatList. The first one is the remove clipped subviews. And if we send this to true, the views that are outside of the viewport are detached from the native view hierarchy. So on Android, this is automatically defaults to true. And from the benefit is that this can reduce the time spent on the main thread. It can reduce the drop frames, but at the same time, it can lead to some bugs. So I would recommend, probably unless you need this, not to add it. So if I do remove clipped views true, this will detach the items that are outside our viewport, that are not being visible on the screen from the hierarchy. If you're not doing anything crazy with, see, something is going wrong there. It started jumping back and forth. And most probably that's because of this remove clip subviews. Even though the user interface everything is fine here. The next one, max to render per batch. How many items should the FlatList render every time? So the more items we set for the FlatList to render per batch, the longer the JavaScript execution will process, and this can hurt the responsiveness of your application. But the benefit is that setting bigger number means less visual blank areas, because if every time we scroll, the FlatList will render a lot of items, like 50 items. The chances are that we see blank areas is less, but at the same time, the main thread can be blocked and the application can be less responsive. So if we have buttons and so on, when this is happening, the buttons will not respond to click events. So this is, again, something that should be done with cautious, and it works together with the maximum render per batch, which defaults to 10 items. Works together with the update cells batching period. That basically means how often should the FlatList update or re-render the batches. How often should it check if it should render the batches? So the if you provide a small value, the FlatList will try to re-render these batches very often. And again, like if you do this, if you provide a low value, The FlatList will do these updates very frequent, and this can lead to your application being unresponsive. But the benefit is that you'll see less blank areas. So again, you need to find the balance, or you just go with the defaults. Initial number to render, this is how many items to render initially. And this is, we can set this one to a lower value, and it will load the application. The initial load will work much faster. So initial numbers to render, for example, if we do 2 here, then our application will load faster. By default, the value is 10. If you provide a very small value, you might see, yeah, as you saw, initially the FlatList only render the first item, and only then it render the second one. So a very small value is also not something very desirable, but because you are gonna see like this, like first, second, and third, and so on. So add a number here that you are sure will cover at least one screen of visible area. In my case, I'm sure that at least on one screen we can fit maximum, I know, 3 items. So I would go with an initial number to render 3, because on a bigger iPad or something like that, maybe we will be able to fit 3 items. If you are building a FlatList similar to TikTok, where one item is full screen, in that case, go ahead and go with an initial number to render 1. And this will, when the application starts, the FlatList will render only the first item, and then we'll go ahead and render the others. And because the post is full screen, in your case, that's not gonna affect anyhow the user experience, but it will improve the speed and performance. So I'm gonna go back to, I don't know, 3 or something like that. Knowing how many items I can fit on my screen will help me understand the initial numbers to render. This one I recommend trying to set, because you can improve the initial load time. Next one is the window size. This one, this is the default 21, and that's where that's what I was explaining you before. By default, the FlatList will render 10 viewports above, 10 below, and the one that we currently see. This can be adjusted, so the window size, if you provide a very small window size, for example 3, and if I will open the debug, the FlatList will only render 3 viewports above and 3 below, like this. This way it will consume way less memory, but at the same time, it increases the chances that you're going to see white screens, because it's much easier to get outside of this window size. Maybe I'm going to do 1, and this is only going to mount the components that are currently in the viewport. So again, it works well because this iPhone is quite fast, but on a lower device, on a lower end device, you're gonna start seeing white screens. So yeah, window size is how many items the FlatList will mount at any given point in time, or let's say the minimum amount of items it will mount at any given point in time, because it will usually mount more of them. For example, it always mounts the top ones because you can always go back there. If you scroll fast, it will try to load more below, so it optimizes this, but this is going to be the minimum. So as we can see, the pro is, as we increase the window size, we will result in less chances of seeing black spaces, but on the other hand, smaller window sizes will result in fewer items mounted simultaneously, saving memory. This is the how's it called? What we gain and what we give. So if we need to save memory, we're gonna provide a smaller window size. If we need less chances of seeing blank spaces, we're gonna provide a larger window size. And that's most of the configuration around the FlatList when it comes to the performance. There is also the, yeah, this one. While we're still here on the list, there is also, I'm going to scroll down, the key extractor component. And this is also a property of a FlatList that helps improve the performance of the FlatList. Remember, every time you wanted to, I'm gonna do it like this. For example, if you had an array A, B, and C, and you simply looped through that array, let's say view, and you did array.map value, and you render the text with a value. Whenever you have done like the simple mapping, most probably you encounter this warning that says each child in a list should have a unique key property. Why this is happening? Well, this is happening because this is how React handles the caching of the items whenever we have lists of items, lists of items. And array.map is a very primitive way of rendering a list of items. So usually what we had to do is we had to provide a key here. And if I provide here the key value, which is the value A, B, or C, in that situation, I get rid of a warning. So the trick and the rule of thumb is to always provide the unique key to items inside a list. Well, our FlatList is also a list, so it should follow the same rule. Every item should have a unique key. The thing is that I don't see this error here. Why? Well, because FlatList is smart enough to use, if I'm gonna look at the data here, FlatList is smart enough to look into the data and check if the item has either ID or a key property and use that property as key, for example, ABC, and use that value as the key of an element. So in our case, the data has ID, so that's why we do not see an error, so we don't have to do anything. Continue like this. But in some cases, for example, if I'm gonna remove this ID from here, and in my list, instead of items, if I'm gonna send character.results, we are supposed to see like this character.results. Not sure why now it doesn't. Let me try to remove everything just for me to be able to see the warning. No, it doesn't want. But anytime that your data doesn't have this ID or key property, in that case, you will need to provide a function called key extractor. And here you need to specify how can we create a unique key knowing the item. So here we're gonna receive an item, right? Item ID, yes. And for example, you're gonna say that the key will be the name of our item. We shouldn't destructure it, it's simply item like this. So again, if your data doesn't have an ID or a key property, you should and you must provide a key extractor function that will receive the item that is rendering, and you need to provide a unique value as the key that will be used by React when rendering this. In some situations, you might also be interested in the index, and I think the second parameter here is the index, and you can provide a key that is made out of the name and then dash index. That would also work. In my case, I don't need that, so I'm gonna remove it, but just know where and why do we need the key extractor function or property of a flat list. Okay, another aspect of improving the performance of your flat list is improving the performance of your individual list items. In our case, our flat list is rendering the character list item. So the more performant this list item will be, the more performant the whole list will be. That sounds obvious, but that stays at the core of improving the performance of a flat list. Because yes, we can adjust like some of these things, but if our list item that we are rendering is unoptimized and it does a lot of calculations every time it renders or every time it re-renders, and if it's very heavy, in that situation our list will start feeling sluggish. So I would recommend starting with improving the performance of your list. In our situation, this is a very quite performant component because it doesn't do anything, any heavy logic when rendering. It simply renders to a text and an image. If, however, you are doing here some data fetching or some calculations every time you re-render, in that case, you need to think how you can optimize that. So let's look at some advice to how we can improve the performance of list items, thus improving the performance of a whole flat list. So yeah, the recommendation is to use basic components. The more complex your components are, the slower they will render. Try avoiding a lot of logic and nesting in your list items. If you are using this list item component a lot in your application, create a component only for your big lists and make them with as little logic and nesting as possible. Again, yeah, try to have as little nesting here as possible to improve the performance. Nesting means using here another component, and in that component another one, and in that one another one, and so on. So try to have like a very basic one that contains most of the code here. Avoid heavy images. That's very important, and especially like if you're building an application that are using images. In a lot of situations, the performance is affected by the sizes of the images. So in a lot of situations, you are simply loading the images as full size when you can, and it's recommended to use a lower version of the image and maybe progressively load a better quality image. For that, we have an actual a tutorial on our channel. So if you go here, I think it's under our videos. It should be 1 second, or that one was the live stream. Image performance, this one. So by simply, instead of loading like, as I show here, instead of loading 4 megabytes images, if you would optimize your images and load, for example, a 34 kilobytes image, your component will render faster and it will feel faster. So check out this tutorial if you are interested in how to optimize images. And again, at the incubator, where we helped developers build and launch applications, I showed them this one. I showed our startups this one, and it improved the performance like significant of application, because they had these issues of very slow loading lists and we didn't know why. And I just looked into it and it was like loading 20 megabytes images when you could optimize it and load a couple of kilobytes of images, and maybe even later load a better quality after your list or after your data has finished loading. So yeah, that's not necessarily, let's say, about React Native or React, but that's in general like networking and data. Like less data you're gonna download, the faster your the faster your application will fill. The use memo. So the use memo will help us optimize our component and re-render it only when it needs to be re-rendered. So let me check how I can show you this one. So in the character list item, let's say, let's console log here, let's say re-rendering. And here I'm gonna say character.id. Now let's open here. We see re-rendering 1, re-rendering 2, and re-rendering 3. But in my list, I will go back here to items. So initially we see that almost all our components re-render. That's okay, that's fine. But as we will scroll, we see that our components are being re-rendered because some of the components get outside of a view, some of them still have this issue. If I broke it with a refreshing. On refresh. So yeah, let me get back to the re-rendering. So initially we see the components from 1 to 19 being re-rendered. That's okay because that's the first time they render. But as I scroll, some of them will start appearing in the list, some of them will disappear. But the problem is that when this happens, like most of our components are re-rendered, because if I will clean and do a bit of scrolling, not only one component is re-rendered, look, everything from 1 till 15, 16, and so on till 51. So that means that what's happening here is we are, for example, loading new items. We are updating this state variable. And whenever we update a state variable, the component re-renders. The fact that we are re-rendering the list, that's perfectly fine because we need to when the items change. We need to re-render to render new items. The way it works is that by default, all the children components of this component will also re-render. So all the character list items that are mounted, they will re-render. The thing that we do not see the items from 4 to 12 being re-rendered just because means that they are unmounted. Everything else that is mounted are re-rendering without having to, because the data or the properties didn't change. This comes from the fact that, yeah, when a component re-renders, it re-renders all the children component that it uses. In this case, re-rendering the list will re-render all the character list items. Well, we know that if the character ID didn't change, or if the character data didn't change, it doesn't make sense to re-render here because we know that nothing changed. So to do that, what we can say is we can memoize this character list item and we can decide ourselves when do we want to re-render it. We want to re-render it only when the character data or the character property has changed, not anytime that the parent component decides. So for that, we can use the memo hook from React. So let's import memo from React. Let me see how can I do it better. This is the component. Okay. And we should wrap our component inside this memo hook. I'm not gonna put it here because I think it's going to confuse like the structure. I'm going to wrap our exported component in the memo. So we need to put it inside the memo. And the memo expects a function where we will decide if it should re-render or not. That function will receive a previous props and the next props. We need to return true if we want to re-render and false if we need to return true if we don't want to re-render and false if we want to re-render. So in this situation, we see that we are simply comparing the titles. What I'm going to compare is previous.props dot character, and I'm not going to compare the whole character. I'm only going to compare the ID of that character, because I know if the ID didn't change, the other data also didn't change. And I'm going to compare it with nextprops.character.id. Now, if I will refresh everything, initially it re-renders because this is the first time, but as I will scroll, we see that it re-renders only one. And when it does that, it doesn't re-render the other ones, because for the other ones, the ID didn't change and we don't have to re-render. So as I will scroll, it fetches more, it renders them, but we don't see duplicated re-renders. So that improved the performance of this list by memoizing our character list item components. This is great strategy to use, especially if your component is heavy, especially if your component is doing a lot of logic here inside it, or it's very hard to render. Because in a lot of situations, if your component is very light, it would be faster to simply re-render it than to check some of these, to do these checks. So rule of thumb is try to keep these checks as simple as possible without having to JSON stringify stuff or parse information. If you have an ID, that would be the best way to check it. And if you know that, if you're sure that if the ID didn't change, the other data also didn't change, that's going to be a good strategy. And for small components, don't be afraid of re-renders, because sometimes it's faster to re-render a component than to do a check like this. So that's about memoizing components. And let's see the comments. So debug cannot work while the data is less than one index, which happens when first load and reloading in your examples. So the guy is saying that my problem with debug here fails only when items array is less than 0. So I can do a check here if items dot length is less or equal than 0, or if it's equal to 0, then I will return nothing, because this is only to make the debug prop on FlatList work, because without debug we don't need this one. So whenever you have debug equal true, by sending the debug simply the name, it will send the value true. So now if I will refresh, yes, it works. Thank you very much. Thank you for helping me fix this issue as well. Hey, how to know which post we are in, for example, to update the number of views? Not sure what exactly you mean with updating which post we are in. Oh, I think I know what you mean. How to know which post, okay, which post is being rendered on the screen so that we can, for example, update the number of impressions of that post, right? That's a good point. Let me try to cover it at the end. Bonus on viewable items changed. I will do that. Yes, I'm gonna show that. Remind me after I finish with the performance to show this as well. This is a quite common and important thing to know about the FlatList, how to do that. Please talk about how to handle like 3-column layout. I had a really hard time when using FlatList for 3-column thumbnail layout. There was so many blank spaces. Let's do that as well. Multi-column layout. Yeah, I see that you guys are interested in this topic, and I'm okay with answering and showing exactly what you are asking. So if you still have questions, write them down, and I'm gonna continue this live stream and implement them. So far we are going to talk about how to determine when a component is being rendered on the screen in order to, for example, increase the number of impressions, and also multi-column layout. Talcon is asking about the Tamagui takeout. Talcon, I'm not sure if I will be able to help you right now. This is a bit off topic, but reach out to me, or the Tamagui takeout has a Discord channel, and for takeout users, they have like a separate page where they will answer the questions. Okay, so let's continue with some of the performance. Yes. Also speaking about images, well, the recommendation is to use cached images. So even if you load small images from your server, that would be the work of your backend to optimize them and to store them, to store, besides the original, to also store a lower resolution version. That would be on the backend. On the front end, however, what you can do is you can cache images locally, and you can accomplish that using libraries like React Native Fast Image or also the Expo image. That will help cache these images locally. So between re-renders, the images will not start loading again. They will be in the cache, and it will improve the performance. Everything that goes with images and unoptimized images will impact the performance of your application. The next one is get item layout. This is a great area where you can optimize your flat list, especially when you can calculate the size of your container that is being rendered, and this by being able to calculate the size ahead of time, the flat list will not have to do these calculations as you scroll, like dynamically. So if your components or your posts are fixed width, or if you can easily calculate their sizes based on some information about the items, in that case, this can help you. So let's see how we can use it. If your list item components have the same height, providing the get layout prop removes the need for your flat list to manage asynchronous layout calculation, which are expensive. This is very desirable optimization technique. If your components have dynamic sizes and you really need performance, consider asking your design team if they may think of a redesign in order to perform better. So again, yes, if your components have the same sizes, and in my case, they have the same sizes. If I look at the character list item for the container, we see that even though the container doesn't have a width, our image has width 100%, which means that the width of the image is the width of a screen. When the aspect ratio is 1, the aspect ratio of an image is 1, that means that the height of an image is also equal to the screen width. We have a name at the top that has a font size of 20, which is the height of the text, and also has margin vertical 10, which means 10 at the top, 10 at the bottom. So the name has a total height of 10, and the image has a total height equal to the width of a screen. So if we put them together in my list, let's see here, const item height equal to 40 for the header plus the screen width. How do we get the screen width? We can do that using the const use window dimensions dot, or maybe here we can take the width. So this width from use window dimension will give us the width of the screen. And because our image has aspect ratio of 1, meaning that the width and the height are equal, we can calculate the whole item height by adding the width with 40. Now let me do the following. How can I test this assumption? Character list item. You don't need to follow this. I'm just gonna on layout. Get the height of a component. On layout, from the event, I'm gonna get the width. So on layout, you don't have to follow this one. I just want to get the actual height of this layout and then compare with the one that I calculated. So here I can do console log height. Height from React Native. And here in my list, I can do console log height that I calculated. Item height. And I really hope that they will match. If I open, height from React Native, 437. And the height that I calculated, 433. There is 4 pixels of 4 pixels difference. Most probably because the font size 20 doesn't mean that it has the, because if I will say font size 0, no, font size 0, font size 20, does it mean that it's the height of this name is 20? Not sure. If I will add here height 20, now these digits will match, right? 433, and I'm also doing 437. So the question is, how can we get automatically the height based on the font size? Not really sure, but we can provide a static height to our text component as well in this situation, like 20 or even 20. 5? No. 20 is okay. So the height from React Native matches the one that I calculated. Yeah, I calculate 43. And that means that I can use this item height in the get layout, item layout, And by doing that, we can get significant improvements. So let's check the documentation of get item layout. Get item layout, we need to provide the length, offset, and index. Any examples? Get item layout. Length, offset, and index. That's what we need to return from the function. So get item layout should be a function. It will give us the data, which is the information about the item itself, the index, and we should return the length, the offset, and the index. For the index is clear because we need to simply pass the index from here. The length is the item height, and the offset is going to be item height multiplied by index, but also item height multiplied by index. And I need here to put it into like this. But at the same time, in the offset, we need to pay attention to add also the gap and the spacing between the items that we have here. So it's going to be item height plus the gap of 5 multiplied by the index. So yeah, now we are helping the FlatList by providing the item layout and the information about like the sizes without the FlatList to having to calculate it on the go, similarly to how we have done it here. So I'm gonna remove it from here, and yeah, again, this is great when you can pre-calculate and when you know what's going to be the height of your items. And I don't think that this is correct. I don't think that you can only use it if you have the same height of your items. I think you can improve the performance with get item layout when you can pre-calculate the item height of your items. Because for example, even if they don't have the same sizes, if some posts have an image and some of them don't, you have this information here in the data and you can calculate it properly. But again, great improvement for your performance. And I think the last one for the performance, that was our get item layout. Oh, what happened? Yeah, speaking about the performance, the last one is, the last advice is to avoid anonymous functions on the render item property of a FlatList. So what we have currently is the render item is an anonymous function here. Anonymous functions means that every time we re-render my FlatList, this function will be recreated. So this is wasteful because the function can be memorized based on this item. So it can be done here. What we should do is using the use callback. We can define this render function. Render item function. So let's import the use callback from React. Using the use callback, we can define functions that will be memoized, like that will not be recreated every time the component re-renders. So the render item is going to be a use callback. Inside here, we need to provide this render item function, and as a second parameter, similar to the use effect, we need to provide the dependency list that will trigger the use callback to recreate this function. Our function is this one. let's copy it, and I will actually replace it like this, because the use callbacks also has the item. And when should this render item change? Well, never, because it doesn't depend on anything. It will receive an item and it will use it here to render the character list item. So I can use render item here instead of defining anonymous function that will be recreated every time. So now it also works. Counter to children. Where do I have this bug? It should be something with not setting correctly the next page. On and reached next page. Very weird why it happens. I'm sending probably two requests with the same page. I think it started happening after I well, anyway, not sure exactly where it's coming from, but probably from for calling the same function twice with the same URL, with the same page. But yeah, we have covered this use callback to replace our anonymous function in the render item. And that's the most important performance implementation that you can have to optimize your long and large flat lists. At the end, the rule of thumb is, first of all, see the amount of data that you're rendering. And remember that blobs like images or videos, these are heavy objects that requires a lot of network data to be loaded. So whenever you're working with them, try to optimize them. When you're working with images, instead of querying the original size images that usually are a couple of megabytes, try to fetch a downsized version first, and later you can replace it with a better quality. But that will by far have the biggest impact on the feel of the performance of your list. Then you can look into improving the performance and the complexity of your list item. Try to have it as simple as possible. Avoid a lot of heavy logic that is happening on every re-render. Avoid a lot of deep nesting into the list items that you have here. And the next step is going to be to memoize it if there is heavy logic here. Memoizing it will help us re-render it only when we actually need to do it by comparing the properties. After you have done that, you can go into and look into performance properties of a flat list, like how many items to render, like the window sizes and so on. But these are more advanced, and usually like you would need to work with them in only like in very advanced situations where you already finished improving the performance of your items that are being rendered. And by pre-calculating the height of your items, you can save FlatList some work because it will not have to recalculate it every time. You will provide these values automatically. So that was the performance and how you can improve it for the list. Now I'm going to go into some bonus features. I'm gonna go through some of the questions that you have asked, and let's go ahead and do that by simply do git status, git add, git commit -m performance. And the first question that you guys have asked is about how can we know, or how can we know when one of these items gets on the screen actually, and this would help us, for example, increase the number of impressions a post received. To do that, there is a property of a FlatList called onViewableItemsChanges. OnViewableItemsChange is called when the viewability of the items is changing. But what does it mean? Well, we first define like when should we consider an item visible on the screen, and then this onViewableItemsChange will be called with the new items that appear on the screen and the old ones that disappear. This property helped us, for example, pause the videos in a TikTok clone after they leave the screen and play them when they enter. It also is the property that helped us understand which item is currently selected in the Airbnb clone when we swipe through the items, so that we can link the map together with a FlatList. And it's also the same properties that you can use to increase, for example, the number of impressions of your list. So on viewabilityConfig, it works together with the viewabilityConfig. And let's go to the viewabilityConfig to first of all configure this one. ViewabilityConfig. And with the ViewabilityConfig, we define when should the FlatList consider an item visible. And there are a couple of properties, like the minimum view time is going to be the minimum time that an item is on the screen before the FlatList considers it visible. Because if you simply scroll through a lot of items very, very fast, you don't want to consider them visible. You need them to be on the screen for at least some time. So let's go ahead and for the ViewabilityConfig here, let's say minimum view time should be 200 milliseconds or even 500 milliseconds, like half a second. Only then we will consider them that they are visible and we can increase the impression. The next one is either we will choose between either working with the view area coverage percentage or the item visible percentage. This means how much of the item should be visible on the screen for us to consider it visible. And it works here in the item. It works based on the amount of the item being visible on the screen. And in the first one, it works based on how much of a screen is dedicated for the item. So one is, for example, if item visible percentage, if we're going to do here 0.5, that means that if more than half of the item will be on the screen, we will consider it visible. The other one, view area coverage percentage, if we do that 0.5, that will translate in English to if more than half of the available space on the list is taken by this item, only then we consider it visible. So in cases where your items are small, I think it's better to work with the item visible percentage threshold. Okay. You can read more about them here. And let's go to the on viewable item changed. And this is a callback. This is a function that will give us changed and viewable items. So that means that it's a function that will give us changed and the, how is it called, viewable items. And what we can do here is simply do a console log. I'm gonna console log the name, and then I'm gonna console log the items that have changed, their viewability, either they appeared or they disappeared. And also we can check the console log, the items that are visible on the screen. So now if I'm gonna look here, and as I will scroll, we will see what? onViewable items changed, and the first one is the changed items, and this one is an array of items with their indexes that have changed their viewability. For example, the item with index 2, which is Morty, it became viewable. It has the is viewable. You don't need the item, but for example, that's it. It also shows us how many items or which items are currently visible on the screen. It shows us both index 0, index 1, and index 2. Now, as I will scroll, we're gonna see that the indexes and information about the items that have changed their viewability. So what you can do probably is for your use case, I think I can do it like this: if changed dot is viewable, right? If change is viewable, no, changed is an array. So changed dot for each changed item, I will check if changed item dot is viewable. That means that this item just got into the view. So what I'm gonna do is I'm gonna do console log ++ impression for the item with ID. Let's call the changed item dot ID. I'm gonna comment this out and this as well, and let's see if this will work. So impression for the first one, for the item with ID 1 and for the item with ID 2. That's correct. If I'm gonna go down, we're gonna see impression for the item 3. But why? I think it shouldn't be 0.5. I think it should be 50, because I expect at least 50% of the item to be visible on the screen before increasing the impression. Now, if I'm gonna scroll, even though we see summer here for a bit, we are not increasing the impression because it should be at least 50% of the screen to increase this impression, and at the same time it should be at least 500 milliseconds on the screen to consider it visible. Because if we scroll very fast, we're not gonna increase the impression for the items that we just went through them and didn't stop to actually look at it. All right, that's good. But and lastly, yeah, that's how you can do it using onViewableItemsChange and viewabilityConfig. Another thing about these ones is, yeah, you cannot change them on the fly, and also in a lot of cases you have to memorize these items because it will keep giving you errors. For example, if you change stuff like, I don't know, from gap 10 to gap 15, that I think has to trigger the problem. I don't remember exactly when. Maybe it was fixed, but by giving these values directly here, by giving them here, sometimes it gives you errors when you are simply developing them. So what I recommend doing is I recommend extracting this viewability config from here into a separate object that we will memorize, but I will also look at another property that can group together the config and the callback function. And I think that is called viewabilityConfig callback pairs. This property allows us to combine two of them together into the same property. How do we define them? Let me just double check it. The callback pairs. It doesn't provide a lot of documentation. Yeah, it doesn't provide a lot of documentation, but let's see together. For example, viewability config callback pairs. What does it expect? It expects an array. So we are going to provide an array. Of viewability config and on items changed. So an array where we will put these two properties, but make sure to remove a set of brackets. And the second one is going to be it should be an object with two values, viewability config and on viewable items changed, which is this value. So now we have put them into a pair, and this also allows you to have different viewability configs, because with some configuration you want to increase the, let's say, the number of impression. With some of them, maybe you want to increase the number of views. With some of them, you want to synchronize something on the UI. So you can have different configurations and different logic that should happen when this does. And you can do that by adding different configurations for viewability here. Very powerful to have like different callbacks and different things when items change visibility on the screen. And we see that we cannot change that on the fly, and that means that I'm going to have to memorize this value, the whole array, here. So let's memorize it using const. Let's call it viewable item like this, equal use memo. And use memo, similar to use callback, allows us to memorize a value. And we can provide here the dependency array that will recalculate the value when something changes. In our case, the value is going to be this array. So let me copy array. And from the use memo, I'm going to return the array. And I'm going to use the viewability config callback pair here. Will this work? Render more hooks than during the previous render. The items length 0 should be the last thing before the return. So let's see if we still increase the impressions. Yes, we do. 3 and 4. Scroll. Impression for 15. For 16. Yes, that works. Let's add a comment here. In use case, Siri, what's going on there? Increase, stop it. I'm afraid I couldn't. Increase impression count for posts that are visible on the screen for more than 0.5 seconds. Okay, so that was answering the question for how we can do that. Git commit, git add, git commit. Let's do it like this. To increase impressions when posts are visible on the screen. Any questions about this so far? Crystal clear, thank you. Appreciate it. Key extractor, we covered that. We talked about it. Jefferson is asking, hi Vadim, I have a question. If each FlatList item needs to validate whether a delivery date is expired with each FlatList update, how can performance be improved? If each FlatList item needs to validate whether a delivery date is expired with each FlatList update. Good question. And I don't think I can help you right now. I would need to see a bit of code to see what are the bottlenecks or what are the things that make it slow. Because at the same time, you want to re-render or recalculate this expiration date every time the FlatList re-renders. So yeah, need to see some code to see like where the performance might be lacking. And okay, so moving on, the other question that we received. The other question that we received was about multi-column layout. So for example, if we want to render the characters in multiple columns, how can we do that? In a FlatList, we can do that by providing the number of columns here. So for example, if I provide 2, we are supposed to see them in 2 columns. Well, problem is that now we do not see that in the 2 columns, but at the same time, we know that the second character in our list was Morty, not Summer. So Morty is somewhere there on the right. Why that is happening? Because if we look into the character list item, what's happening here? We see that the container or the image has width 100. What if we say that the container has flex 1, and this will make the one container or one character list item, by saying flex 1, it will tell it, hey, share the space that you have on the same row between your siblings. So because we have 2 columns, the character list item will share the space between the two columns. If I'm going to increase it to 3 columns, it will automatically resize it in order to fit properly like this. So I'm going to leave it with 2 columns. And once you have this, and another question is, okay, but how can we add some spacing or gap between them? The content container style, the gap that we add here, this is going to only be, the gap is going to only be added between the rows. If we want to add gap between the items as well, there is a property that we can send here that will specify the style for one row. And it's actually called column wrapper style. And if I add here gap 10, similarly to how we have the gap between the items on the top, we have the items here as well. So probably gap 5 is going to make a bit more sense. What's happening there? Gap 10. Viewability config on the fly is not supported, so it still fails. I think this one shouldn't be done with use memo. I think this one should be done with a use reference, with a reference. So let me try to change from use memo to a use reference. That is going to be imported from React. A use reference doesn't have a second parameter, and the callback pairs, when using them, we will have to do .current. And it shouldn't be a function, it should be like an actual value. So I will remove a function. Where is it? The function, and also the return, and leaving only the array here. So now it works, and if I will change things like the gap here, it will still work. So yeah, instead of using use memo for the viewability config, which is still going to be re-rendered when we remount the component, and instead of that, I'm using a use reference and the .current here. Okay. And when we have things like this, I really like to do border radius 10. Hey, that's nice. Where is my list? My list. To have more space between the rows. Maybe. All right, so that's how we can render multi-column lists, and everything else remains the same. Everything that we learned today is going to work the same here. But I'm really not happy with the duplicated items, because that means that we're sending the same request twice. Not sure when it's happening, but it's happening. Is it happening when we refresh? Now it's not happening. When I'm trying to fix it, it's not happening. So yeah, that's our long list of items that we can loop through. Automatically paginated, it's an infinite list, and as we scroll, we load more items. Let's do git add, git commit, and this is going to be our multi-column layout. All right, guys, so that was also the bonus features that you have asked. Let me know if you have any more questions. Yeah, Jefferson is saying, I believe there isn't much I can do in this case. I have this function that gets the status and color for the items using notjust to calculate status color, get priority color. Yeah. What you can do now that I'm thinking, Jefferson, is you can memoize your components similarly to how we memoize the character list item here with the memo. In our case, we said that, hey, you need to re-render only when the IDs will change. But in your case, you will have multiple conditions here. For example, you need to update when the ID changes, but you also, for example, need to update when the next props dot, let's say, character dot due date is more than a new date. So that means that only re-render if you change the data or the ID of the item. Should it be and or war? Wait a second. Keep the same. Yeah, I think it should be and. So don't re-render it unless the due date is over the date. So in this case, a lot of your items will simply not be re-rendered because their due date is not changed. And when they will be changed, when the date will be passed, it will automatically recalculate the color and re-render the color. But yeah, this might be a bit tricky. So it's just an idea. Meister Elo, I can ask another one. Render header from the top of a flat list and make it fade when you start scrolling. Is this part of a flat list? This you would achieve in a combination of flat list properties and some animations. We saw in the my list, in the flat list, that we used this list footer component that renders some items at the bottom. In a similar way, in the my list, you can render a list header component that will render at the top of your screen, for example, text, here, title. This title is going to be rendered before all the items. So if I refresh, we see here title. So with some style, you can have height, I don't know, 200. If there will be a lot of things here. And but in your case, it's a bit different. With a list header component, the things that we render here, they will scroll together with your items, like usually. This is great when you have like some items that you actually need to scroll together with a list. In your case, what you are recommending or what you are asking is to have something that is actually above the list. So we will have to move this text being rendered above a flat list. In this situation, the title or the text will always be here and the list will scroll like this. So this is the first step. To accomplish that, you'd have a header at the top and then a flat list here. And the next step is going to be to animate the height of a header based on the scroll of the flat list. For example, on scroll, there will be the event that you can check, and you can, based on the console log event dot native event dot content offset, this will tell how far are we. Based on this content offset, we can animate the height of a title. So as we scroll, the height will get smaller and smaller until it reaches, instead of 200, it will reach, I don't know, 40 to only show the title and still be there. So that's what you're trying to accomplish. But in this situation, you'll need to use, like, for example, an animation library like Reanimated, which is out of the scope for this tutorial. But just as an idea, that's how you would accomplish it. Very good. Thank you for your help. You're welcome, Jefferson. Kiwum, 1 second. I'm gonna find it. How to solve React Native screens was not found in UI Manager. Try to install the React Native screens package. K1 is saying we want the next stream to implement native code and to use React Native, which functionality is not possible in React Native. So yeah, Kiwum is asking about native code and native packages. Okay, I'm not promising it in the next stream, but we definitely have to do a tutorial on that. So I will add it in our idea list. Anyway, guys, I really hope that you enjoyed this tutorial and you learned something about FlatList. If you did, make sure to subscribe to the channel, not to miss our future videos. And if you are on your journey to become a React Native and Expo developer, we actually have a premium course for that that you can find at academy.notjust.dev. This course goes in depth in all of the topics about building full stack and performant mobile applications. It teaches you everything about React Native, about AWS Amplify, to build both backend and frontend. So yeah, make sure check it out if you're interested to upgrade. And also I would like to say a big thank you to the sponsor of today's video, StepZen. And this week on Friday, if you're watching this live, we have a crypto price tracker that we're going to implement using IBM StepZen. I know a lot of you wanted to see a crypto price tracker in a while. So here it will be. And if you're watching it later, this video should already be on the channel, so you can check it out somewhere close to the video that you found today. All right, guys, thank you very much for being here with me till the end, and I will see you soon. Bye-bye.